Okay, okay.
So it's real quick. I just want to say this and then we'll get into review. Okay, lines, that's the most general form of a line, really. There's the standard form of a line, which is crap. This is the practical, useful formula. And of course, why? Because this is the slope and this is the y-intercept. Kick ass. So no matter what the line looks like, if I solve it for y, everything falls into place. I can identify the most important graphical aspects of this from its equation. That idea holds for just about any shape and its equation. Right? So like we saw with a parabola, if I put it into this form, what can I see? Tell me, there's a few things you can see. Tell me something that you can see from this shape, from this form. Vertex, what would the vertex be? H. Okay, kick ass. What else can you tell? Okay, line of symmetry, affectionately known as the LOS. So x equals h, right? Because it goes right through the x piece of the vertex. What else can you see? If a is greater than 0 or less than 0, then it opens up or down. I like it. Okay, cool. So you just take the algebraic expression, you put it in the right form, and key things about the shape come out at you. That only makes sense. We graph something based on results from its equation, therefore the equation should have something to tell me just by itself, without me plugging shit in. Lines do it, parabolas do it, and so do circles. Can somebody tell me the two most important things about any circle? So if I have a circle, the radius, circumference is related to the radius, so I can calculate it if I knew the radius. So the radius is kind of like, and then I can calculate the area and all this shit if I just knew the radius. So it's fundamental. The radius, right? It looks like a little Pac-Man that just kind of like, what else? This is kind of weird, but what if I took that same circle, didn't change the radius, but I moved it somewhere? What would change? Center. So remarkably enough, I'm going to call the center HK. You guys, am I with me here? So there should be a form that I can put a circle equation in so that those things jump out at me. And here's the form. So if I saw a circle equation that looked like x minus 1 squared plus y plus 2 squared equals 49. Let's start off with what would the radius be? What would the radius be?
7.
Yeah, why? Because 49 must be r squared. It's in the right form. So whatever this number is r squared, therefore r is 7. What would the center be? Be just a little more specific. No. Positive 1, negative 2. Kick ass. I want you to realize something. When we did y equals x squared, it made it curve like this, but these were unbounded, right? Do you see how this is squaring both the x's and the y's? I like it. And there's a lot more to this I wish we had time to talk about, but basically, if I square two things and they come out to be a number, let me see if you guys get this. And this will be the last thing I say about this. To you guys. Can anybody figure out, just look at this. First thing is, can somebody tell me what the radius is? Let's just do these two things real quick. 2, I love it, because that's the radius squared, so the radius must be 2. Because it's in the right form. Does somebody see what the center must be? This is a little weird, but what's the center? What's with the x?
1.
Nothing. Doesn't say x minus 1. So there's nothing with the x, right? There is 0 with the x, and there is 0 with the y. So it's a circle that hasn't been moved. It's still sitting at the center. The origin, right? The origin is the center. You guys semi with me? Some of you guys are just like staring past me, like your Bran. If you watch Game of Thrones, it's like looking at Bran. Why did we make him all this way? But now watch. Now that's two things just straight up. That's the idea that carries through so many things. If I put it in the right form, I can see the most important visual aspects of that thing. That's a beautiful idea. On one level, it's like, well, of course, freaking hell. I graphed this based on this formula, so that just makes sense. There should be some connection. But can somebody tell me? We're only using real numbers, right? It's a slice of the real numbers I'm graphing. What's the biggest x could be? What's the biggest x could be and make sense? I know that's a really weird question to come out. Try to make x 3. What does that say then if x is 3? 9 plus the square of something is 4. Which means the square of something has to be negative 5. And since we're dealing with real numbers, is that possible? No. So the biggest x could be is 2. Or negative 2. They both are the same because I'm squaring the damn thing, right? So they both come out to 4. And if x is 2, y is 0. So what's the biggest y could be? 2. Same reasoning. And that's why it goes out 2 in all directions. Like it? And man, I so lied to you. And I don't care because I just decided. So what about this shape? What shape is that? Besides a horrific something melting. I don't know, sorry. Let me draw it like this, that's better. So that, anybody know what that shape is? It's not an oval necessarily, it's a more specific shape. It's like what orbits are in. Elliptical. Or an elliptical machine, because if you actually trace out the shape that your feet make, it's an ellipse for an elliptical machine. So this is an ellipse. Now I want you to see real quick, just, I was about to say something, but you've done it all semester, just bear with me. This equation looks almost like a circle. The only difference is something like this. When I put stuff in like that, you see how the coefficients are not the same. So it's going to go in the x direction differently than it will in the y direction. That's what makes it kind of longer in one direction or longer in the other direction. You guys see that? But it should still be a circle. It should still have the same idea of somehow coming back on itself, and that's why it's a sum of squared things. It's just that the x and y piece don't have the same coefficient. So it's going to go out longer in one direction or the other direction. That's what makes it elliptical. Okay, that's plenty. Sorry. So if you go into pre-calculus, you will start from scratch, basically. So anything I show you is sort of a, kind of get you ahead of the game a little bit. But you will talk about circle equations. And hopefully you understand, you might have to complete the squares. See there, you have to complete 2 squares now for x and y to get it in the right form. That would be the algebra behind that. And then ellipses aren't that different from that. And then you got these freaky ass hyperbolas. I'm not going to talk about those. So comets could have a hyperbolic orbit where they come in and then they almost hit us and we all freak out and then they go out and they never come back. Halley's Comet has an elliptical orbit, right? You guys know Halley's Comet? It's the one that comes back. Mark Twain was born when it was there and he died when it came back. And he was kind of like, man, why didn't we invent something to shoot that thing out of the sky? Maybe we could have lived longer. But too bad. Probably not. It's probably not true. All right. That is it for new stuff. Yay! And that stuff is not going to be on the final or anything. I just wanted to get that in your brains so you can see how it's the same idea, just keeps building. I love that. The same idea, it just is used broader. Okay, so now we could do whatever. We could talk about that quiz. We can talk about the practice final. If you don't have any questions, you can just start working on corrections to other quizzes, other tests. If you have quiz 1 and you never corrected it, correct it, turn it in. You might get something, right? It's a little bit late. But if you get enough right, you might get something. You with me? So anything. So if I were you, the very first thing I'd worry about is correcting any tests I haven't corrected. Because those are the heaviest weighted things. You with me? And in the process of correcting, you're also studying. Isn't that crazy? So you're up in your grade twice over. Yeah. That hurt.
What if we did on the...
If you did what?
Good.
If you did good, feel great. You should do fine on the final. Those things will be on the final exam. Yeah. To be honest, I didn't feel, I don't know. So you guys understand, the end of the semester is busy for everybody, right? I didn't have time to sit there and figure out how to finagle getting some points in there, so I just didn't count it for anybody, right? That's why there's no grade on there, okay? Yeah. But if you did well, great. You should do great on the final for those. That's going to be on the final again. You know it. And that time I'm not going to hold back, right? So right now is a great time to discuss ideas that you didn't get for that.
For the number 1. Yeah. That equation to the x minus h squared.
Number 1, you don't have to use that at all.
Okay.
You don't. You could, but like I said, I wouldn't, right? So number 1, I think we already did one like that. I kind of did one like this. I can't remember what it was. And the shortcut to find the vertex was the x piece was what? What's the shortcut to find the vertex? Yeah, negative b over 2. So if I just say find the vertex and whatever else, and that's all I say, don't put the thing in standard form. Should you be able to? Yes. Will I ask you a question to do that? Yes. Would you do it when I don't ask you to? Why the hell? There's so many places you could make a mistake. But I still have to eventually test you on it, do it, so I can see where you make a mistake, or if you do you guys follow what I'm saying? So if I just say find the vertex and maybe some other stuff of this, and I say nothing about putting it into the parabola form or whatever, I wouldn't if I were you. Especially if there's a number out front, that freaks everything out, right? And I think yesterday, didn't we do this both ways? I'm pretty sure we did, yeah. Is that cool? Okay. So definitely want to use that shortcut if that's all I ask. But on number 3, I think it was on the quiz, I asked you to put it into that form. Yeah. Notice that number 3 I was kind of nice. I didn't put A down there because it was a 1, so I just made it more direct. Yeah. Is that my one question? Oh. Oh.
On 11.3.
11.3?
Yeah, like 51.
51? Oh, yeah. All right. That's just a ton of fun. So, quick primer problem. If I tell you that the solutions to some quadratic thing are -1 and 5, where did that come from? Yeah, and then you just multiply this stuff out, and that would be the answer. Okay, right? So how would it have changed if I would have put 7 and 3? It wouldn't have changed, right? Why is this x plus 1? Because it's always x minus an option. So x minus -1 is plus 1. Some of you guys might realize that relates to the whole HK thing from before. That's why it's the opposite sign. So what if I said that the solutions instead are 1 plus rad 7 over 4 and 1 minus rad 7 over 4? There you go. Shit. And then you just brute force the bad boy, right? It's going to be x minus this one times x minus this one equals 0. Right? And it's just, you know, part of me wants to go too damn bad. Just multiply all this shit out. I mean, it's part of what you have to be tested on will be some, can you just stamina your way? Do you have enough stamina to get through a problem like this? I'm not going to make every problem like this. But the first thing I could do is everybody with me first off? I mean, the idea did not change a bit. It can't. But the things I'm working with are a little bit worse than -1 and 5. So that's why what I do feels different, but it's exactly the same idea. Now I got to multiply this shit out, but it'll be a little bit easier if I first kind of break things up. And now you just have to multiply x, multiply the 1, multiply. Right? Okay. I'm not going to stand here and do that, but.
Could you factor out x minus 1?
I want you to realize you can only factor stuff out if they are involved in a product. This is x minus 1, minus is x minus 1, plus, you can't ask, factoring has nothing to do for that. I like it. I like the way you're thinking though, you're trying to think there's got to be some way to make it simpler.
Yeah.
But there ain't. Believe it or not, it'll actually, I think, well, I don't know the way I was, but I don't know the way they set this up. The radicals, in the problem they gave you, I think the radicals should cancel. They might not always, if they just make one up out of nowhere. And all right, so let's do a little review of something. It's going to connect to that problem over there. What do you got, Jeff? Okay, sure. How do you solve that? If this was sitting in this middle of a big section of solve this problems, what would you do? What do you try first?
The little term
What about?
divided by 2.
Oh! No. There's so many reasons why not to. Sometimes completing the square, that's what you're thinking of, is actually a little bit quicker than quadratic, but not very many times. Especially when the first number is not 1. So you'd have to factor 2 out first, and then cut 3 halves in half. And I don't want to. What's the shortcut to completing a square? Quadratic formula. Quadratic formula does the same thing completing the square does. It just did all the work already. So when we write quadratic formula, we're starting at the end. That's why it's a shortcut. You guys semi with me? To be honest, the very first thing you should try is to factor this thing. Right? Part of me just died a little bit because nobody suggested it. Or maybe you guys realize they ain't going to factor.
I saw the grade.
-8 that makes negative, no, it's not going to factor. Shit. So what's the quadratic formula?
X equals negative.
Negative b, so -3. Give or take. B squared.
Minus 4 is
Yep, -4 times a times c. Is everybody with me? All divided by
2a.
2a. So you get 3, give or take, square root. Let's see what this is. A times 4 is 32, right? The negatives cancel.
Yep.
So you get 9 plus 32 is 41. You with me? So I get 3 plus rad 41 over 4 and 3 minus rad 41 over 4 as answers. And do you see how this started with, what if the answers were this? All right, well, what if the answers were this? If I did that shit, guess what I end up here? Do you guys? So this is a nice review of quadratic formula, but I want to point out that that's why something that looks so disgusting, if you did this backwards, plug these, in here, do all this shit, guess where you end up? Of course you end up there. Because that's what leads to these answers. Do you guys follow? Maybe. Okay, maybe. So I understand when you look at this, you're like, there's no way in hell it's going to come out nice. But there's an example of one that we know how it started. So of course it would have to come out nice. The radical shit's going to cancel. And why does it make sense the radical shit's going to cancel? Because what are these two things to each other? Anybody remember the name? No? Conjugate. I like the conjugates, yes. Nobody got that stuff? Okay. All right. Yes.
You do a matrix problem?
Oh, sure. So I'm assuming you mean, you know, like something solvent. So let's see. Oh, let's see. I think that's that. Yeah, okay. All right, so take a second to write this is the matrix. Made room on this thing. Hopefully so. So what's a
1, 0, 0.
oh? Are you talking about? So what's your goal? I don't know if that's what you're talking about.
Yeah.
That's what you want to eventually get to. That ain't where it starts though, right? I got an X, I got a Y, I got -1Z. Oh, don't do that, Jeff. And keep going.
2. -1. Right. Oh.
I like it. Everybody comes in on the course. I like it.
-3.
4, -1.
All right. Now, there's something I've done that's kind of nice. What's in the right place? That's the right thing already.
The 1.
The 1. So if this would have been a 1 here, I would have just switched these two rows, or these two equations, or I could have just switched the two rows. I can just switch rows. Because did the equations have to be written in this order? Hell no. Right? You guys with me? That's why you can switch rows, because who gives a shit what order the equations were in? So why is that nice? That's already a 1. It's supposed to be a 1. That's awesome. So what can I do with this 1 to start creating? What is it I'm trying to make? Zeros. Because that means I'm killing letters. Here I go, killing letters again.
Multiply over 1 by -2.
Yes! So I can kill that 2, make it a 0 like I want it to be if I multiply this row by -2. In fact, it doesn't really matter which column you start in. You guys see that? As long as my suggestion is, whatever column you pick, you finish it before you move to another one. Otherwise, you start doing this whack-a-mole thing with, I got a 0, I killed a 0, I lost my 0, I made a 0, I lost a 0. Holy shit, you just kind of like going in circles. That's why I normally don't make this the first problem, because then somebody will never finish anything else besides that. So yeah, if I multiply twice row 1, -2 row 1, right? Add it to row 2. Put the answer where?
In a row 2.
Because what am I trying to make right now? Why am I doing this? I'm trying to make a 0, and where do I want the 0 to be? There. So I'm going to put the answer in row 2. Okay, I like it.
No.
So So what I suggested was instead of rewriting everything, just put what the answer would be once you multiply everything by -2. So -2 plus 2 is 0. -2 minus 1 is -3. 2 plus 3 is 5. -2 plus 4 is 2. Now let's see if I can push this shortcut idea a little bit further. I'm done with these things, right? They only existed for a second, so I can kill that 2. Now that the 2's gone, the assassin goes away. How do I kill this -3? Multiply row 1 by 3. I like it. There you go. Put the answer, of course, where? Row 3. Why? Because I want a 0 there. Also, I don't want to lose my 1. I don't want to overwrite row 1. Because I got the 1 right where I want it to be. Yay. Okay. So put the answer row 3. So 3, 3, -3, 3. So that's what it would get if I multiply everything by 3. 3 minus 3 is the 0 I wanted. 3 plus 4 is 7. -3 minus 1 is -4. 3 plus 0 is 3. And then the first row just comes back in. So I picked column 1. I didn't have to, but I just did. I used the one that was there to kill the other two things. What does this equation say now?
0, -3.
What is the equation that this represents?
Oh, 2. It was 2x.
No. What does this say now?
-3y
-3y
plus 5z
plus 5z
Equals.
equals 2. Did you have to do any of that for no? But this is just me making sure you understand the concept again still. Right? Every step I take creates new equations. Okay, I like it. So now what do I do?
Don't you want to get a 1 in that middle?
Yeah, I need a 1 in here. You never have to make fractions, right? So let me see if you guys... So here's the most direct thing you can do, because I have a feeling that fewer of you will like the other thing you can do. Let me show you this one first. How do I make a 0 show up here? How can I make these kill each other? And then remember what I said? It's like LCD. If I can build these up to be the same number, they'll kill each other because they're already opposite sides, right? So of course, they each need each other. Aw. So if I'm going to play him by 7 and him by 3, they'll both be 21s. Just one of them be negative. They'll kill each other. They make a 0. So I don't need a 1. What's the most important thing? Make zeros. Why? That relates to killing variables. There's too many freaking variables. Got to kill a few, right? We're like Thanos. Sorry. Sorry. I got to like this. But in order to make a 0, I don't need a 1. 1s are kick-ass. 1s kick so much ass. I see them as lasers. And I can make them whatever I want to kill this other thing. Kill it. Right? But I don't need a 1. I can make a 0 other ways. The most important thing in a matrix is making zeros in the right places, because that represents killing letters. There's too many freaking variables. Maybe. Okay. So if I multiply this one by 7, and multiply this one by 3, this will still be 0, -21, 35, 14. This will be 0, 21, -12, and 9. Come at 12. There you go, buddy. Come at 21. There it is, man. So what's it look like now? The first row is just sitting back, waiting. 0 and 0 is... Where do I want to put the answer to this, by the way? Where do I want the 0 to show up?
At the bottom.
Yeah. So 0 and 0 is 0. -21 and 21 is 0. 35 minus 12 is 23. And 14 plus 9 is 23. Oh, thank God, Jeff. You made a problem that works. Now, here's something I don't know if I made any big deal out of at all, but what can I do now in that last row? Yeah, and in doing that, I'm making a 1 in that last column. So if I divide that last row by 23, that's what the last row becomes, right? And so this is the one thing that goes against my little rule about finishing up. I can now use that 1 to kill these two things. You see that? These are zeros, not going to screw with anything. So that 1 can kill those two things. Okay. I don't want to take too much time on this, but I mean, if I multiply this last row by, actually, if I just add it right to row 1, right?
Yeah.
What would row 1 become now?
1.
If I take row 3 plus row 1, 1 plus 0 is 1. 1 plus 0 is 1. Negative 1 plus 1 is 0. 1 plus 1 is 2.
Yay.
And then how do I use this to kill that?
-5.
Yeah, multiply n by -5. So I get 0 and 0 is 0. 0 and -3 is -3. -5 and 5 is 0. -5 plus 2 is -3. Oh, look at that. You guys see what I'm looking at that
Now,
made me geek out?
finish the middle column.
Yeah, this I can divide by -3. Make a 1 here that can kill that one. That'll be done. Yeah, you are.
Wait, would you divide by 3 to leave a -1?
Yeah, you could. I like that. So divide by 3, this guy. So I'm going to get 1, 1, 0, 2. 0, -1, 0, -1. 0, 0, 1, 1. So Jeff's suggestion was to leave the negative, and that makes sense because then it can just kill that 1 directly. So then you get 1, 0, 0. 0 and 1 is 0 is 1. -1 and 1 is 0. 0 and 0 is 0. -1 plus 2 is 1. 0, now I'm going to go ahead and divide by negative. Is that cool? 0, 1, 0, 1. And then 0, 0, 1, 1. So what's the answer? X is 1, Y is 1, Z is 1. And that's how Jeff made one that worked. He kept it simple. Jeff can learn. Alright, so I don't know if that quick thing did anything for anybody, but any specific problem, you got to figure out, and what I try to do as a teacher is point out what are the important things. What about this problem tells me what to do? Or what is it that I'm looking for, right? Okay, so you guys look dissatisfied, but I'm not going to turn this into a matrix session because there's going to be at most one matrix problem. So guys are figuring out, I wonder how much they can count that for. Can I just skip it?
How long is the final, do you know?
I do. We have 2 hours for every final, so it's going to be a little longer than a normal, well, let's see, we normally have an hour and 15 minutes. So I have a little more time on the final, so I can put a little more on there than normal. And there's a lot of shit, so it's probably a good thing, right? There's not enough room for everything, so exactly what will be on the final, you'll find out when you take it. That was funny. I don't know.
Are we gonna have any of those like most area problems? Or, like,
Could be, yeah, the optimization stuff.
yeah.
Yeah,
Can we kind of go over them?
okay. So let me give you an example of one I've done in the past. I'm not going to do the same one on the final, but it might be something like this. Let's see. Let's say I have, oh shit, well, let's see if I make something up that actually works. Give me a second. Yeah, okay. 25, okay. So I got 25, let's say I got 25 feet of fencing. I know a lot of these problems have to deal with, we suddenly become very rural in these problems. Rural. So 25 feet of fencing, and I want to construct something on the back side of my house. Here's my house. I want to construct this. Oh shit. So what is the max area I can get from that? So what it is on this side might be foxes, and this side hens, or this side would be hobbits, and this side's orcs. Something that I want to keep separate. So I need another fence running down the center. So remember these problems were tell me, ask me. They tell me I got 25 feet of fencing. They ask me for the maximum area, right? Maybe.
Yeah. So you know the perimeter, right?
It's not really perimeter, is it? Because where does a fence have to go? Here, here, here,
Yeah.
and here.
What would be
So. How long is this?
W?
I don't know. Okay, so call it W, which means this is W. And how long is this? L. I like it. So how do I write an equation for what they tell me? They tell me I have 25 feet of fencing. So how does that go into an equation for how do I construct this from 25?
3W.
Yeah, 3 W's
Plus L.
plus L is the total 25 I've got. We're going to use all that fencing. Because I don't want no fencing laying around. I'm lazy. Put it all up and forget about it. Stick my hobbits and orcs in there. All right, and now they ask me about the area. What's the formula for the area? I like it. L times W. And a real quick, I don't know if I ever told you this story. Give me a quick second. And you're like, you don't have a choice, so too bad. I was doing this problem once where we said we cut a board into 2 parts. And we had to set up an equation. It was like 8 feet long, and this part was half that part, or whatever. And somebody in the back of the room said, I'm a carpenter, and you lose about 1/8 of an inch of wood in the teeth of the saw. So it was a valid point. And I said, okay, you can set your equation up that way if you want to. The rest of us are using lasers or something, right? So we're not losing anything. And you still would, but I won't. So, do you guys realize that I am losing a little bit of area because of this fence here? But don't worry about that. We're kind of like in an idealistic situation at this level, right? The further you get in math, one thing that happens is you start bringing in more variables. You start worrying about more things. So if I drop something, we've had a problem in the book about dropping something from the top of a building, right? Was there anything in there about air resistance? No. So you'd have to add a term to the equation that represents how the air resistance would slow me down. Did we do that? No. Because we had idealistic, we were in a vacuum when we were dropping this. I have no idea how the person survived long enough to drop this thing in this giant vacuum. And they killed over because he can't breathe. Okay. So let me remember what to do now. I've got these 2 equations. What do I do with what they tell me to help me with what they ask me?
Area equals 3W plus L. Since we already have that, or no?
Say again, sorry?
Well, we already have the equation for length times what, 3W plus L, right?
That's not, this has nothing to do with width times length. Do you see that? They have the width and length in it, but this has nothing to do with width
Yeah,
times
they're
length.
adding.
Yes.
W.
Solve for, well, I don't want to solve for W because then I have to divide by 3 and make fractions. I can solve for L. That makes sense. So now I know this is true. This is true, period. Is there somewhere else I see L?
You plug it into the.
So then I can replace L with this. And when I multiply, what kind of thing do I get? What kind of thing is that? No. Is it a circle? Is it a line? Parabola. How do you know that? Because it's a square. Right? So what's this number? What letter do we represent this number with? A, because it's in front of the squared piece. What's the shortcut? Because what would the answer be? What kind of parabola is this? Opening up or down?
Roll down.
Down. The number in front of the squared piece. So what's really kind of wrong with this? It's in the wrong order. Now we can see there's A, there's B. Since A is negative, it's opening down. That makes sense for the question, don't it? It's the only way you can have a maximum on a parabola is if it opens down. How do you find that maximum? Well, the other name for that is and I have a shortcut to find that, right? You don't have to complete the square or anything freaky. You guys look so excited. But anything where I say find the maximum profit or find the minimum cost or find the maximum number of watermelons I can grow or something, it's going to have a part where they tell me something and a part where they ask me something. And then it's a system of equations. I'm going to bring in some more technical terms now. System of equations dealing with L and W. I can substitute. That's exactly what we just did. Remember substitution method? Solve for a letter and plug it in the other dude. That's exactly what we're doing. Because I have two equations with the same two unknowns. I can use them to help me figure things out. You don't have to hit them. Now I can see now that I've made a kind of disgusting problem, but oh well. I was trying to think ahead a bit, but I couldn't figure out what number to put here to make it come out nice. Because what's the shortcut now? What's the shortcut to find the vertex? Negative B over 2A. What's B? And what's A? Yeah, so you get 25 over 6, which, I'm sorry. So let me see real quick. Allow this, right? So obviously for the final, I would take some time to figure out what numbers would work. But if I just make this 24, do you guys see how that's going to help out? Right?
Or simplify it?
Because now there'd be a 24 here. You guys okay with this? I don't know if anybody out there wants to throw their hat up in the air, but I just want to make a number that gets us so we can go a little further.
Yeah.
I'm not going to give you something 25/6. What's that?
4.
Yeah, 24 divided by 6 is 4. The negatives cancel. So the width is 4. That makes the length what? How do you get the length now? I know the formula for length. 24 minus 3 times 4. 24 minus 12. 12. 4 and 12 what's? Feet. I like it. That would give these orcs and hobbits the most area to roam around in without them getting in trouble roaming into lava and shit. So this was the word problem type that was associated with solving those quadratic equations.
Solving for the vertex gave us our W.
Yes.
Okay.
Because again, in general, if I have this, the shortcut is x is negative b over 2a. Well, instead of x I had w, so now it's w equals negative b over 2a. That letter doesn't mean shit. Why did we pick x? There's actually a really interesting history about why we picked x, and it has nothing to do with pirates and treasure maps. Right, but kind of forgot most of it, so I'm not going to go into it, obviously. But it doesn't matter what the shit letter's there. It's just there as a placeholder. So if I put a w there, well then w equals negative b over 2a. It just finds the value for that letter at the vertex. That's all it does, that negative b over 2a. So it could be whatever letter is there.
It's like
Oh.
to the power of some big number.
I to the power of Grayskull. So, oh my god. So I to the 91. bracket. Let me show you a different way, because it looks like some of you guys, let's do it the way I taught you, and then I'll show you a slightly different way. So the way I taught you, and you remember the way I taught you to do this? What is it about I? It repeats every fourth one, starts over at 1 again. That's why it kind of makes sense that if I divide by 4 and see the remainder, I can see where I am. And what is that pattern?
0, 1, negative.
I squared is, and I cubed is, and then I of the 4 starts over again, right? Sure. So if I divide by 4 and see the remainder, I see where I am in this pattern. So if 4 goes in evenly, it's 1, because that means I'm at the beginning again. 4 goes into 91. Well, watch how you can do this. What number right below 91 does 4 go into? You can do it, you can do it. 88.
Yeah.
And which is how far away from 91? 3. So it would be remainder 3, so it equals I cubed, which is negative 1. Now here's another way to do this. Right? That's it. I can't. You divide by 4, you see what the remainder is, and that's going to be the result. So you have to have these memorized. And I gave you that little visual. I have no idea if that helped anybody out. But that's the thing I wish I had been shown a lot earlier in my own education. So you don't feel like I should say this, but you're welcome. The other way to do this, so this is one way to do this. This is the way I showed you. Here's another way to do this. That's amazing, right? Sorry. Ooh, Jeff. But isn't this I squared to the 45th? So see how I had to bring the extra I out because it's odd. So if I leave an even amount over, then and I squared is the one you really should know the most. Yeah. And what is negative 1 45 times? Is it going to end up negative 1 or a positive 1? It's the only two possibilities. Negative, because it's an odd number. So then negative I, which is exactly what I got up there. Right? So you could kind of break it up to be, so if I had I to the, you do
Negative.
66, huh?
I was hoping to do a negative.
Okay, I did negative 66. That's right, because I think, did I put that in the practice file? So, the first thing I'm going to do is this. Does that make sense? Okay, and now keep going. So now if I do it this other way, I to the 66 is I squared to the what? 33, right? What's I squared? And what's negative 1 to the 33? So the answer is negative 1. If I do it the other way, 4 goes into 66, who gives a shit with 2 left over? I squared is negative 1. So whichever way, I saw some people doing it this way, and I kind of always forget this way exists. Because this is kind of important to know, and that method sort of like sidesteps this. But it's still a valid method. There's nothing wrong with doing it that way. In case you have a tutor show you that way, it's fine.
So you prefer number 1?
I do, because it reinforces this idea, which is kind of important. This idea which relates to the image of turning, and that's why a square root of negative 1 makes physical sense. It's not just some weird imaginary shit like its name implies.
Yeah, I did it the way that the top said, but it's like,
What was the way the book did? I didn't have any. Oh, don't worry about it. Was it not one of those two?
it's a little bit different for number 2.
Okay. I'm not going to worry about it. All right. The next thing is we have tomorrow too for this. So you have a little more time to try out some more practice final stuff. Try to finish out homework and bring questions, right? So I'm cool with stopping now or not, either way. It's up to you.
I don't think I know what I don't know
Yeah, it's the worst. That's a good point.
yet. Yeah, so.
The things you know you don't know, those are good.
Yeah.
Things you don't know, those are the ones that I ask questions about in the document. Sorry.
9.2, question 13. I don't really know.
13? Oh, I think we did this one.
Yeah.
All right. So you got 3 ideas because you got 3 unknowns.
I struggle with like the creating like the box that is the grades and stuff like that.
Oh, screw it. You don't need any of that shit. All right.
No, at least not for this one, but like.
Not for this one.
Boxes for like that.
Oh,
Or stuff like that.
yeah, okay. I'll tell you, for this kind of problem, I normally don't give that kind of thing. The thing I do that with is like a distance or a time problem. Those require you to make the little chart, and there's only 2 things. It's a little bit better.
Yeah.
Yeah, you don't even need it here, to be honest, but it does kind of help organize stuff. That's really what it's for. But, all right, did you want to look at 13, or do you want to look at?
13,
So we're looking at number 13 on section 9.2, if you want to. Or you can leave, it's okay. I'm not going to think less of you. All right. This is the one, you guys might remember this. Reba worked in at Starbucks, and she left her cup on the set. And it's got 3 ideas, which are going to relate to 3 equations. And I need 3 equations because I have 3 unknowns.
Yeah.
Right. So, one equation deals with the number, the easiest equation. What are my unknowns? What are my variables going to represent? And you can just look at the question for that. Oh. So she's got 12-ounce cups, 16-ounce cups, 20-ounce cups. They all cost a certain amount. How many cups of each size did she fill? So there's my unknowns are the 12-ounce, the 16-ounce, and the 20-ounce. 12, 16, 20. I love going to Einstein Bagel and being able to order a medium instead of a grande. There's something about that. Just damn medium. So you have to give these things names. So the number of these, that's the variables. Where did I get that from? The question. So what are you going to call this one?
Tall.
X. That's crazy. Oh shit.
Tall.
It is Starbucks in the problem. I can call it S, M, and L for small, medium, large. Or you can call it X, Y, Z. Doesn't matter.
Yeah.
Right?
So this is number 13 on 9.
13 and 9, 2.